Hello, hi everyone. I am audible. Please ping me in the chat. Okay, so let's do it for 2-3 minutes and then we will start. Good afternoon. Hello everyone. We have good amount of attendees, so I think we can start. Shall we start? Please ping me in the chat. Okay. So you may get some background noise as well due to construction work near to my home. So if you are getting that kind of weird kind of noise, so like please tolerate for today only. Okay, so in today's project discussion, so we are going to discuss how to handle when we have a target, continuous kind of a target. Let's suppose you want to predict a price of something or a salary of employees or like a stock price, stock market related kind of a thing. So there, this is called a continuous feature. So I hope you are aware of continuous and categorical. I'm going to share my screen and let me know is the screen visible or not. Is the screen visible? Okay, sounds good. So today's session is related to the stock price prediction, where specifically we are going to predict the price of Tesla uh, company. Hope you all are aware of Tesla. And we have a data since 2010 to 2020. So approximately 10 years of data we have for this particular prediction. Okay, so first let me show you the data and then I'll take your question related to the data. So if you can see in the data, we have not a much features. So there is a date on like there is a date-wise data. On that particular date, we have a opening price of a stock, Tesla stock. Then on the specific date, the highest or a maximum like a maximum price of a stock, and then in the low there is a minimum price for that particular date, and then at which amount or when the stock market is closed at that time what was the price of the stock, and then there is a adjacent close feature, and then there is a volume. I'm just going to explain you about these two features. These are the like a technical feature here. Like if you have a like a knowledge related to a stock market, then you would have already understand those features. If you do not have any if you do not have any like information related to stock market, so you couldn't get understand these features. So this is there. So let me show you. Next thing is let me tell you about the features here. So there is a adjacent features over the time of that is like of the stocks can change for different reasons. So let's suppose like never stocks remain stock price remains same. So it gets changed like time by time or day by day or yearly. So adjacent close number is like how many times that particular price has changed, the number of times the price has changed. So this called as a adjacent close adjacent close. And in the volume how the total amount of a trading activity has happened on that particular specific day. So this is related to volume. I hope these two are like a technical terms here and these are clear to you. Just let me know in the chat. Okay. So as I'm receiving most of yes, so I hope you have cleared these two things there. And then later on, I checked the head of the data and then the tail of the data, what kind of a feature we have there, and then the shape of that particular data. So here we have approximately 2,400 records and seven columns, and the columns is date, open price of a stock, closing price of a stock, highest and lowest at that particular specific date. So these type of information we have, if you'll see there. So date is in object format, and open and close and all other features are in the like integer and float data type. So which is completely fine, but data type should be in the date time format. So we need to change that particular date time format like we need to change that particular date column into date time format. We will do it later. And apart from there, if you see, there is no nan value, like luckily. But let's suppose if you would have some nan values, if you would have some nan values, let's suppose in the open or a high or low, so then what would be your approach? Can you let me know, like if you have some nan values in let's suppose in opening price of that particular uh, if there is a nan value in the open column, stock price open column, so then what would be your approach there? I'm asking hypothetically. Okay, fill zero, replaced by mean. Okay, so I got what I wanted. What previous day value? Yes. So the answer, correct answer is like a previous day value. So if we have a nan in opening price, there must be some closing price for previous day. So we need to fill accordingly. So this is not like this, like that you can fill by mean or median always. So you need to think differently, like what could be the reason and how I can fill the opening price is there. If you have, let's suppose, some missing values in the high and the low, so there you may apply a mean and median. But in opening price, you can relate that particular opening price with the closing price for like what was the closing closing price in the last date. So this is how you have to think, like some logical thinking you have to apply while dealing with these kind of a data. So as I told you yesterday, you should have a like a domain knowledge. Without domain knowledge, it's little bit difficult to like complete a data science project. Next thing, if you'll see, as I already explained, so most of the feature are in the correct data type, but data should be in pd dot datetime format. And I have just like using pd dot to datetime function. I'm making a correct format of that particular date column, and after that you will check. So now datetime column in the correct format, and then so if like you have a date, so you are not going to like use a date in the column like in a model. So we cannot give a date kind of a column to the model. So that's why we have to either drop it or make an index of that particular kind of that these kind of columns. It's kind of a like a customer ID, like we had a customer ID yesterday. So this is same kind of a thing. Nothing is like fancy here. So after this, if you will check unique value, so checking unique value doesn't make sense here. Just I have like printed like to give you some more clarity, but it doesn't make a sense since we have a continuous data here. So instead of printing the unique values, you can print a different graph for that or for all the features, which I have plotted. I'm gonna show you in some next slides. You will get a yesterday recording as well, so it will be uploaded or like it already been uploaded. You can check. Okay. Like checking like a unique values in continuous data set or data continuous data doesn't make any like a sense there. Okay, so let me could you let me know like can we drop like blindly some feature, or should we use some statistical analysis, or how we can select the best feature here? Just let me know. So what could be the best approach here to select the best feature or dropping a feature? Okay, I'm getting from someone, I'm not audible. Is this correct? I'm audible to you. Guys, please let me in the chat. Yes, if you like most of you are able to uh, able to hear me, but like if you are getting any kind of a trouble, so I would request you kindly rejoin and like a voice or audible issue will be sorted. But volume is very low. I hope now it's clear. I have raised my volume. Actually, I have a throat problem, so due to this, I'm not able to like. Okay. So yes, I'm getting answer as a correlation check, a correlation multicollinearity. Yes. So these kind of a statistical analysis we need to perform, like whether there is a difference between these features or not, or you will check a correlation. And there are multiple kind of approaches. You can use any one of that approach. So it's up to you, like which one you want to apply. So there is a filter base like a statistical test you can use, t-test, chi-test. I hope you all are aware, like where we need to use a t-test and z-test or a no and chi-square. So using these kind of a test, you can select the best feature. Apart from there, we have a machine learning model as well to select the best feature. Okay, so now let's check. Is there any duplicates? So there is no duplicates in the data set. And now let's start from visualization. Now I'm going to explain, like I have created a heat map using, I have like, this is a describe, like tf.describe, just there I have used a heat map to for better visualization. So for each variable, if you will get a clear picture. So in the opening price, the maximum value is 673, and in the closing price, there is a maximum value is $780. So here you are getting a mean values, median value, and standard deviation. So all the parametric like mean, median kind of things you are able to see here. And then I'm checking what is the relationship between opening and closing price. If you'll see, so there is not a much scattered data. We have a linearly kind of a data. So as you can see, as opening prices increase, so closing price is also increasing. Or in other word, we can say if open price is same, so for that particular that particular day, the closing price was also same. There is not much difference between closing and the opening price. There is only one records which opened at for a specific day. It would be for a specific day. So if you'll see, the opening price is around 700, but closing price is 800. So it happened due to some very uncertain event. Like it could be anything, someone has praised the Tesla work or something like this. So due to these kind of a reason, it could have it would have a there is a sharp jump in the stock price for that particular specific day. So we need to identify as well these kind of a situation as well, like why this there is a hike in the closing price. So yeah, due to some kind of a very unpredictable situations, it has been there. Okay, so similarly, you can perform a you can create a different kind of plots there in between two or three features. So similarly, I have created a plot between low price and the closing price. If you'll see there, there is a pattern, like a correlation between these kind of features. Like if one is increasing, the other was is as well increasing. But in volume and closing, if the volume is high, then the closing price is not much high. So most of the records are in most of the records are near to each other. There is not much scattered. They are not much scattered. So similarly, between volume and the high, you can create a number of plot and graphs there. So I have created all the plots between two variables, uh, closing and opening. Like you, I am creating a uh, since here our objective is try to predict like what would be the closing price for Tesla stock for a specific day. So since close is here target variable, so that's why I'm checking what is the correlation between close, which is a target variable, between other features like open, high and low, and then there is a volume. Then you can create a different plot between all the features, and you will try to extract the information as much as possible using different kind of a plot. So after this, I have created a line kind of a plot. Like I'm just checking how the how, like what was the performance of the stocks in past 10 years. So in x-axis, I have taken a years, and in the y-axis there is the price of the stocks. But if you'll see from 2010 to 2020, so there is not a much till 2013 there is a not a much spike in the stock price. But after 2013 there is the price is gradually increasing, the stock price is gradually increasing. But in 2020, we you would remember there was some controversy related to a Tesla in 2020, and the mm, Elon Musk has tweeted something related to Tesla, and then the price has spiked suddenly. So due to that particular a very uncertain and predictable behavior, the price has spiked uh, uh, heavily. So that's why there is in 2020 the price has gone up to a $800. So in what is the pattern? What is the behavior of opening and closing and maximum and highest price? So this is that particular graph. So there is not like this. Like if price has opened at $400 and suddenly it has closed on $800. So there is not like this. So there is a little bit difference if $1 or $2 or $10. Like if price is has opened at $400, so it closed on the same day at $410 or $415. So there is not much spike in opening and closing, or like highest and maximum for a specific day. And then checking outlier, whether there is any outlier in the dataset or not, using a box plot. So you also can check to you also can check there is other technique as well to check outlier. And if there is outlier, we have to handle the outliers. What are the ways to handle outlier? Just let me know. In the in What are the ways to handle outlier? Remove the outlier. Like how would you remove the outlier? Like you cannot drop the outliers. You have to handle them. You have to shrink the you have to shrink them. Yeah, using Z score, like there is a Z score, or there are other formula as well, like on the basis of the normally distribution. So if the data is yes IQR, there are five ways. Yes, there are many ways to handle outliers. So if your data is skewed, so there we go with the IQR kind of a formula. If your data is not it's not skewed, so there you use mu plus minus 3 sigma formula, which is used for a normal distribution. I hope you are aware these kind of formulas. So here I'm handling using a Z score. Using Z score and up uh, after after three threshold, I'm considering them as outlier, and like we can remove the those outliers. Once you have, if you can check like what is the data loss percentage, so it's hardly 2.3, so which is a completely acceptable, like this much of data loss is acceptable. See, if like your business understanding or your client wants you to apply a IQR, or so there you can apply IQR as well. So it's completely up to you. So after removing like outlier, so I have created a plot or histogram. So this is neither this is a skewed nor it is a normally distributed, but yes, so actual data will look like similar to this, but in the volume, so it's looking bit like skewed, rightly skewed. Okay, so after this, once you have handled the outliers, like now your data is like normally distributed, so you are good to go for further steps. Now check the correlation between different features. So if you will plot a correlation between these features, so these features are looking bit correlated to each other. So if you'll see in the in if you'll see there, so between volume and open, so there is 69% correlation. Open and close, it, yeah, definitely these will be the highly correlated. Open and low, open and high, so there is a very high correlation between these features. Okay, so just I have created like what is the bar plot to check what is the correlation. If you will see a feature on the x-axis, so there is a feature on the left axis. We have a target variable, and I'm checking what is the correlation of different feature with the target variable. So if you'll see high price or maximum price, highest price has the highest correlation with the target variable, and the volume is like a lowest correlation with related to a target variable. Since drop is since closing price is our target variable, so we need to drop that particular feature from the data set, and apart from close, I'm assigning to the x variable all other features, and to the y I am giving the target feature, and then applying a standard scalar to so can all the features should be on a same scale. So for that particular purpose, I have used a standard scalar there, and then variance inflation factor, VIF. Do you have any idea what is VIF and why do we need to use VIF? What is the reason, like what VIF does? And if you'll see, so like for volume, I'm getting just a 2 unit values, and for other values, there is a much like higher value. So what is the reason for this? Ensemble technique? No. VIF we checks to check like VIF is applied to check whether there is a multicollinearity between feature or not. So if you are getting a higher value for a specific feature, so that means that particular feature is highly correlated with the other feature. But if you are getting a less value for any kind of feature, so that means there is a that particular feature is not highly correlated with the other feature. So since for volume we are receiving very low value, so this particular feature is not highly correlated with other feature, but these open, low, and high, there is the value is very very bigger. We have a very big value, so there is a multicollinearity between these features. Like if we would have a huge number of features in the data sets, then we would have like selected a best feature. Since we have only 4 features, so there is no need to select a best feature kind of a thing here, because if you'll draw or if you'll drop these 3 features, then you will have only this particular volume feature, and you cannot predict, like you will not be able to build a good model on just a single column. Then we need to create a model. Uh, to create a model, first we need to do a train and test split. For train and test split, you will use this particular train and test split function, and we'll try to find the like a best split, a best random state. So for 139 random state, I'm receiving the maximum R2 score, and then I have splitted the data on this particular random state, and then I created a different model. Now I'm receiving a R2 score, mean absolute error, and mean squared error. So can anyone let me know, like, what is a reason, like why do we use R2 score, mean square error, and mean absolute error? What these kind of a metrics does? Do you have any idea? For accuracy determine, yes. So let's suppose if you have a R2 score, then why we need mean absolute error or mean squared error? If we have a R2 square, then why do we need to use other metrics? Is there any difference between these metrics, or all are same? Mean absolute error says how much error is present. Okay. And other, what other says? All are different. Yes, all are different. Let me know you. Okay. So R2 scores tells us about like how much the data points are fitted to the regression line. So we all know, like we have a regression line in like a linear regression. There we have a line. So when we create that particular, let's suppose this is our created a this is our best fit line, and in R square we get to know like how close the data point are fitted to that particular regression, like how close they are, whether the data points are near to that particular best fit line or they are far from that particular best fit line. So if we are receiving higher R2 square value, that means data points are very near to the best fit line. If we are getting a very less R square value, that means data points are very far from the best fit line. Is this clear? What R score does? It's tell about how close the data points are fitted to the regression line. Now let's come to the next thing is, okay, difference between prediction and actual value. Okay, so difference between actual and predicted values, like uh, let's suppose you are predicting a salary of an employee, and the employee name is like A, and the salary is 10K. This is actual value, but your model has predicted. So prediction for employee A, your model is predicted 11K, or let's suppose a 9K. So here 10K is actual value and 11th or let's suppose 9K is a predicted value. So when we calculate the difference between actual and prediction, so this is done by a root mean square error, or like a mean squared error or mean absolute error. So let's suppose, so how you can do this? Actual minus prediction, actual minus prediction, and then you do a summation, and for each record you do a summation. So let's suppose there is a 11K is actual and 10K is predicted. So there is a difference of 1 unit, and then one will be the like what should I say? Well, then it will be your mean squared error. And in mean absolute error, what we do in mean absolute error, instead of like doing a square, we do a mode. So 11 minus 10, then you are getting a 1. Still you are receiving a 1 unit change. But if you suppose, if you have a huge difference, let's suppose instead of just 1 unit you have a difference of minus 11 to minus 40, so there will be a approximately minus 29 and root square of minus 29. So there the difference will be huge in mean squared error. But in case of mean absolute error, so there you will have a 29 unit difference. I hope this is clear, or should I repeat it? Okay. So next thing is like when you want to check what is the error between actual and predicted value. So there you use mean squared error or mean absolute error. Now the question has arisen like what is difference between mean absolute error or mean squared error? Do you have any idea? Mm. Since we like both are giving the like error, so what is the reason of using both of them? Mean absolute is robust for outlier, correct. And why it is robust? Now let me know you. So let's suppose you have a huge outliers in the data set, or let's suppose you do not have outliers, then what will happen? And if you have outlier, then what will happen? So let's suppose you have a values like 45 is your actual and 56 is your predicted. So we do a summation square. So if you will getting a values like 45 minus 56, like 19 or 11, sorry, there will be 11 square. 11 is 121. So here you are getting a 121 unit uh, uh, as a error. But let's suppose you have a outliers in a data set. So instead of 45, there will be some values like 60. So now difference is 14, and then you will do a 14 square. So definitely it will be a very huge value. So due to outlier, square mean squared error gets a effect. Like there is a very huge change. So there is, yes, there is a minus 11, but when you will once you will do a square, so it will be become a positive. But let's suppose if you are using let's suppose if you are using mean absolute error. So since in mean absolute error we do not do a square of any value, so there we receive the value. Let's suppose if your actual value is 45 and the predicted is 16, so you will receive minus 15. But once we do a mode of any value, so it always become a positive. So here you are getting as a 15. So in outlier of kind of a situation, we go with the mean absolute value. Now I hope this is clear. Got it. Okay. So there is not much difference between categorical and continuous. Like in the end, there we just need to change the model name, and instead of a classification matrix, we need to use a regression matrix. Or okay, one more question: do we need to apply a oversampling or undersampling here? Do we need to make a balanced data set? Because I haven't applied. I haven't used code for oversampling and undersampling. Do we required here? Is our data balanced or imbalanced? Yes, no need for continuous variable. Correct. Whenever you are trying to predict the continuous kind of things, or like you have a continuous target variable, so there we do not need for a like a make a balanced data set, since there is no class in target feature. So this is also the second difference. Any other difference? Other than these two three difference, like there are almost the same kind of a work we need to perform. Like there is, if there is a continuous feature target, if there is a continuous independent variables, there we required a there we need to handle outliers. If there is a missing values, we need to handle a missing values. So these kind of a things we, like these are the common things, and handling missing values, outliers, and making a normally distributed data. Okay, one more question. Why we need a why we need to handle outlier? If we do not handle outlier, then what would happen? Like, what is the advantage or disadvantage of outliers? If you have outlier, then what will happen? Accuracy affected every time. Okay. Any other guess? Accuracy less. Why accuracy less? Or like, what is the reason of less accuracy? Okay, let me know you. So whenever we have a wrong data in overall, no, that's not a wrong data. That's actual data. But whenever you'll see, if you'll read assumptions, like assumption of logistic regression and a linear regression, so they want a data in normally distributed form. So whenever you have a normally distributed data in this kind of a pattern, so these kind of models works well. Why they works well? Because we plus minus 3 sigma, there is a data 99.7%. So in just plus minus 3 sigma you have almost complete data. So that's why normally distributed data works fine in linear kind of approach. So this is the main objective. Like if you have a normally distributed data, your data doesn't have any outlier. So linear kind of a models have assumption, they want a data in normally distributed. But for tree based model, there is not any like this kind of assumption, they works fine. So that's why we need to handle outlier. If you are going with the logistic regression or linear regression or support vector machine or SVM, or if you are using a distance based models like a KNN also affects with outliers. But for decision tree, random forest, XGBoost, there is no need. I hope this is also clear. Anything else? Yes, 68% in one standard deviation, in two 95%, and three 99.7. Any kind of a doubt do you have? If you have any doubt, just let me know, because there is not much to discuss in continuous since we have already discussed about a categorical kind of a project. If you have any doubt, just let me know. Before 3, I'll wrap up this session. If you have any other say classes, so you can like join. I'll wrap up before 3. The project will be completely based on machine learning. Like there is not a specific like on machine learning. This kind of approaches you can solve using a neural network as well. It's not like neural network is also a kind of a technique in under machine learning. It's not a different thing. Due to non-IT background, it's really difficult to remember syntax. Okay, so to remember a syntax, like there is only a one thing: do a practice as much as possible. Only practice is the way to learn all the syntax and the code. When will the videos be uploaded? The first video has been uploaded. If the video still is not there, so I'll try to upload all the videos by to the end of the day. Any other doubt? For one person repeatedly I'm getting voice kind of issue. Most of you are able to hear me clearly. If you have like if you are not able to hear me, just let just there is a problem at your end. Do check. Is it possible to share these notebook? Actually, I don't want you like to copy this exactly code. Like it's not a 100% a right way. I just shown you like the standard way. I request you do like apply your approaches. Do try to explore by yourself. This is the way to handle a data science project. Instead of just copying paste, do practice by yourself. What do we do with the result after running these program? Okay, once you have compared all the outputs, let's suppose with linear regression you are getting a good accuracy, let's suppose 90% or 80% or 95%. So then you do a prediction on the testing data, and whatever the future data you will have, so you will do a prediction on the data and you will share those prediction with the client or the stakeholder or a management. You take decisions based on these outputs. When will we get our first project? So very soon you will get your first project and you will get a like a very good time to complete that project. Is Python data analysis project are different? Like how? I didn't get your question. All the when is the final date to submit the project. So all the information you will get in the comment section. How do you predict? Okay, prediction. Let me show you. If you'll see, so just using a predict function, you do a prediction. Model dot predict, and inside that you gives the data set. These are ML projects. Yes, these are machine learning projects. Okay, so I'm not getting a like much question. I hope I have cleared the all the doubts. So this is done for the day, and still you have any kind of a doubt, I would request you just do a Google. If still you are facing any kind of issue, do contact your SME and they'll try to help you. Okay, bye. Have a nice day.